Afternoon, everyone. My name is Jing Lin from China. I am working in the. I have heard the prayer. I have a short and brief present. Our work is about the couple. Okay. Uh, so firstly, the safety concerns in construction have been mentioned in previous uh, presentations a lot. The first challenge about the aging population, the second challenge of high corollary rate, and the third labor scarcity. So we use the robots in the construction sites to address the above challenges. But there are also new challenges caused by these revolutions. So we want to assess the coupled risk of construction workers' unsafe behaviors in HRIs in our study. We also go back to look the previous work on the identification of independent risks and assessment of coupled risks. For the identification of independent risks in the HRIs, we found they did not consider the coupled effects of the risks. But for the coupled risks works, they did not consider the HRI aspect. So this is our motivation for the study. So we used both the qualitative and the quantitative methods in our study. We use the literature analysis to establish the indicator system and gather the experts' opinions to formulate the optimal set of the third level indicator systems. Then use the hierarchical analysis and the fuzzy evaluation methods to construct the coupled degree function. So firstly, we collected both the review studies and the empirical research to construct the three-level indicator systems. Here are the results we contribute. Compared to the traditional risk analysis, we have the first level indicator of the robot, and we have the different sub-indicators in this level. Then we use the optimal indicator vector of both the influence and the possibility of each indicators to determine the evaluation vector and the weight of third level coupled degree indicators. Then we calculate the coupled degree function. So we found that for the results of correlation degree and weight, the construction workers is the most important indicator for the construction workers' unsafe behavior in HRIs. And secondly, the utility results is consistent with the results of correlation. So here are the results of the coupled degree of the first level indicators. We found that the equipment and the site conditions are the most important. And secondly, we calculate the coupled degree of the subsystems. We also see similar coupled degree between the subsystems. Then we want to compare the traditional coupled degree with the coupled degree in HRI. So we found similar work in the traditional construction environment. We found that the coupled degree in HRIs is lower than the traditional environment. Our explanation is that the presence of the robot reduce the correlation or the coupled relationships between other factors and make the environment safer. For the reliability and the validity, since our sample is small, so we compared the results of different sample of experts and they have similar results. So we think it's convincible for our results. And in conclusion, we established a indicator system for assess the coupled safety risks. And we think the robot related factors should be considered in the design and implementation phase. And the HRI risk systems could be the foundation of new safety management documents, training, and inspections. And I want to show some new works of our team. We want to have some VR-based experiments and studies on the human-robot interaction. So the first video is about the tendencies of workers. So this one is okay, the yellow one is a robot similar to a real robot in China. And the second research is about the human-robot trust with collision in the tasks. And then a little bit advertisement. So I'm handling a special issue in the Journal of Advanced Engineering Informatics about human-robot interactions in construction, and it's still open for submission. Thank you.